Hello everyone and welcome to this video. In this video we're going to talk about Unit 5, Handling Data 4. In Handling Data 4 we're going to talk about probability. First, let's talk about experimental probability. Experimental probability means what? It means the probability of something, or the experimental probability of something. It means the number of times that this thing happens divided by the total number of trials, or the total number of uh, total outcomes or successive outcomes. So let's see an example here. For example, event A is that the same bird lands on Mrs. Leong's bird table before 9 a.m. each day. It does this on 40 days, over a period of 1 year, 365 days. Question A, estimate the probability that tomorrow event A happens, and then estimate the probability that tomorrow event A doesn't happen. So basically, this event happens 40 days, and the total amount of days is 365 days. So to put this as a probability, we put the number of times that it happens over the number of total times. So 40 divide 365, like this. This is the first thing, or the probability of that the event happens. Now, to find the probability of the event that doesn't happen, it means you just have to subtract it from 1. You just have to subtract it from 1. So once you find the probability of an event happening, the other probability, which is that the event doesn't happen, you just have to subtract it from 1. So you say 1 minus 8 over 73, it will give you 65 over 73. Because the rule of probabilities is that all, or the sum of all probabilities will always be 1. The sum of all probabilities will always be 1. Now, that's the idea of experimental probability. And experimental probability basically talks about the experiment itself. It's not a theoretical probability. The difference between experimental and theoretical, that theoretical probability is a probability based on theory, but experimental probability is a probability based on an experiment. So let's move on. We have something called relative frequency. Relative frequency. Now, the relative frequency of experimental probability is what? It's the number of successes over the total number of trials. The number of successes over the total number of trials. Let's take a look at an example. Let me use something that's straightforward. Yes. Let's use this as a question for frequency, relative frequency or relative probability, same idea. Now here, the table shows the results of rolling a six-sided die. Six-sided die. So we have six options or six successful outcomes. We have one, two, three, four, five, six. Now, after doing all the after rolling the die, the frequency or the number of times that we got one is 23. This means we got one 23 times, we got two 22 times, we got three 21 times. So basically, the frequency means what? It means how many times did it land on that face. So it landed 9 times on number 5. It landed 7 times on number 6. Now, the problem with these questions, once you have numbers on both sides, you'll be confused with which numbers you're going to use, because some questions have letters, for example, A, B, C, D. This one will make it easier for you to decide which numbers to choose. But here we or use. Here we have two sides and two numbers. These numbers will confuse you. But we always use the frequency. These are the numbers that we use all the time. So the first step to find the relative frequency, I have to find the total frequencies, the total of frequencies. So I'm going to add them all together to find the total frequencies. Yes, we add them all together. So let's add them together here. Annotate first. So here, 23 plus 7 is 30, right? 21 plus 9 is another 30. So these are 60. Now I added by adding tens. So 30, another 30. This makes it 60. And these are 30, which is 90, and a 10 makes it 100. So when you add them together, you'll get, very good, 100. You'll get 100. So the total frequency is 100. So I'm going to write it here. I'll cover this so I can work here. Or I have to leave it like this so I can use them to answer the questions. Let's see here. Let's put them here. I'll cover this side so I can work here. So basically, as we said, once we add them together, we will get 100. So the total frequency is 100. Now, I'm going to use the total frequency and this frequency to find the relative frequency. To find the relative frequency. By doing what? Very good. By dividing each one by the other. And I always divide by the total frequency. So the relative frequency for 23 is going to be 23 over 100, like this. And you'll write it as a fraction. No need to put it as a decimal. This one, 22, will be 22 over 100. And then we have 21, so 21 over 100. And the next one, 18, so 18 over 100. And then we have a 9, so 9 over 100. And the last one is 7, so 7 over 100. And these are the relative frequencies of each event alone. Now, let's take a look at the questions that they want us to answer. Copy and complete the table. We already did it. Calculate the relative frequency for each outcome. So we already did it. We found the relative frequency for each outcome. We found the relative frequency for each outcome. Okay. Now, we found the relative frequency for each outcome. Now, after doing A, let's take a look at question B. Question B, what is the experimental probability of rolling a 6? As we said, the relative frequency is the same as the experimental probability. So rolling a 6, which is this one, the experimental probability is 7 over 2, over 100, I'm sorry, 7 over 100, because the relative frequency is the same as the experimental probability. Because basically here, we rolled the dice, we rolled the die 100 times, and we got 7 times of 6. This means we got 6 7 times. This means the experimental probability of 6 is 7 over 100. So this one is a 7 over 100. Okay. That's the idea of finding the experimental probability. Now, yeah, that's the question. What is the experimental probability of rolling a 6? So write them as a fraction. We get 6 7 times, and the total is 100. So 7 over 100. That's the meaning of experimental probability. When the die is rolled 500 times, how many times would you expect to get a 6? How many times would you expect to get a 6? So basically, we got 6. So basically here, we got the 6 7 times, and the experimental probability is 7 over 100. What happens if we roll it 500 times? So basically, we just take this fraction and multiply it by 500. So I'm going to take 7 over the 100, like this. Let me do it here. And then multiply it by the 500. Multiply it by the 500, and I will get the answer for this question. Let me put the line. So these zeros will be canceled together. So 7 times 5 will be 35. So the answer is 35 times. That's the idea of answering a question like this. So focus on relative frequencies and experimental probabilities and how to find the answers for this question. Uh, Now, let's check this one. Is the die fair? Give a reason for your answer. Now, if you look at the outcomes that we had, these are the possible outcomes. And these are the frequencies or the number of times that we got these possible outcomes. If the frequencies are not the same, this means that the die is not fair. Because basically, once you have an experiment, the die will not be fair. That's the whole idea, okay? That's it for this question. Now let's move on to another question. Clear this. That's it for experimental and relative frequency. Thank you very much for watching. See you next time.